the load acting. How the loads are acting? It's a kind of impact load. Okay, it's a kind of impact load we can say, or sudden load we can say. If we are facing any impact load on the body, how the body behaves, how the body will get deformed, those things we will find the explicit dynamics. Okay, so I'm going for the explicit dynamics analysis. Okay, for that one we require the body. So what I will do, I will create one body under K class. Like it's a car crash analysis also you can say. So I'm creating a car body. file save as explicit format install. Go for engineering data here. And remember one thing, guys, whenever you're performing the explicit dynamics, always take the non-linear general only, but non-linear. Why? Because in impact load, the body is not elastic. Anyhow, when we are performing the explicit dynamics, we can say elastic crash basis. But because the load is very high, similarly, then we have to perform the so that is so this has been explained here. When see here our body is there. This is two bodies we have here. This is one body, this is two bodies. You can find first this one. Now go for the mechanical environment. The geometry has been imported here. Now we check the materials and assign the chamber units to millimeters. Go to geometry. Change the material. Alloy. This body is your aluminum alloy. This surface thickness also we have to specify here for the wall. Because for example, this is a kind of wall, so the thickness are maybe 20 mm thickness I am taking for the wall, and material I am taking structural steel only. uh, connections will be contact only, contact region. Connection will be contact region, but here it should not be bounded. Okay, if you click on contact region, here you can find different types of connections are there. Bounded means if it is a kind of welding kind of thing, like two bodies are welded, in that case you can take, we can take bounded, but these two are not bounded. It is like a separate bodies are there, like it is getting crashed with them. So in that case we have to go for the operation like frictionless. Frictionless you can see, frictional we can see. Frictional. Supports. Generate the mesh. Mesh has been generated. We have to check once, guys, whether the mesh are getting intersected with each other or not. Why? Because what happened when we assign the thicknesses, what happens is these two meshes are getting intersected. I will show you the thing. Yeah. Either from the bottom side here you can find the meshes of this face and the meshes of this face are getting intersected with this. What you have to do is why it's happening like that. Which when you assign the thickness for this body, it is coming middle, like surface coming middle, and both sides are assigning some thickness. So in that case, what we have to do, we have to go for the option here. It is showing offset type as middle. So change this one to top bottom. So I will go for top. Then we check the mesh here. Now it's coming completely outside. See? Now it's completely cutting outside of the wall. So like that we have to check the mesh here. Then after that one, go for analysis settings. Here we have to specify the starting time and end time. Means between what time, like it's an impact load. So how much time is there between the applying load? That load we have to specify. Initially I am giving like minimum number of seconds, that's okay, and end time I am giving for only 5 seconds. Under 5 seconds the load is applying here. Maximum energy or everything is okay. Yeah, that much. And it will start always from the 0 seconds. This 5 end time as a 5 seconds. Okay. Now the analysis have been done. Now what we have to do, we have to specify the boundary conditions. So right click, and what we have to see here, when this happening here, now the analysis is performing here, the the car should not lift from the ground. That is our bottom. So in that case, what I am doing, what we have to do means we have to fix the bottom area. If we do fix to the bottom area, means the body is completely not moving on the ground. So what we have to do in that case, it should move. See, the deformation will be there on like x-axis and y-axis will be there. Deformations. Okay, deformation should be there in x-axis and y-axis, but it should not be in the z-axis direction. So in that case, what we have to do means we have to specify the displacement, and two directions we have to make 0, and third direction we have to specify, sorry, two directions we have to place free, and one direction we have to specify 0, that is fixed one. So right click, insert, go for displacement. I am selecting these edges here. Select these edges by pressing Ctrl. Apply. Z axis I want to make 0. Okay. Z axis I want to make 0. That is my displacement. Now what I am doing here, I am going to assign the pressure. Pressure I am specifying here. And then this thing, this wall which we are saying the wall here, that one we have to, that one we require the fixed one. Right click, insert, fixed support for this wall. Apply, then right click, insert, we have to specify the pressure. Take this essential body. So we have to give the acceleration here. Acceleration only, huh? Select this body, apply. Velocity we have to give, because speed we have to specify. Go for velocity. In which direction we have to specify velocity? The car is moving in the x-axis, because the wall is in the x-axis direction, so it should move in the x-axis direction. So in x-axis direction, I am giving the velocity to be like the something. 1,50,000 millimeter per second velocity. Okay, now click on solve. Allow access. Here guys, whenever you specify that thickness we have specified to the wall now, other than the middle one, so definitely it will show that error for W. Don't worry, it's a warning, not an error, it's a warning. And error is showing that time step is too small. So here the time step we are getting very small here, so let's check the result. If it is not coming, so we'll check the other things. Okay, so now go for insert, boundary conditions. You have to check the total deformations and right click, insert, directional deformation in x-axis, or because we specify the velocity in x-axis direction. Then right click, insert, we have to check here maximum equivalent stress. Then we have to check here equivalent stress. Right click, evaluate options. It's not showing throwing error. Why? Because the I will remove this stress tool. Now see here, it's getting crash here when we are specifying the boundary condition to the length. So total deformation we are getting as 127.86. You will say that much deformation, how is it possible? So anyhow, it's a crash analysis. The deformation we can, in real time also we can able to see the deformation there. Okay, that is my maximum deformation, directional deformation. In x-axis we are getting, in only x-axis I am getting like 64.373 mm deformation we can able to see. Okay. So like that we will check here deformation. The equivalent stress we are getting here as 1279.9 megapascal. Understand guys? So like that we will perform the explicit dynamics analysis. So like that we can understand guys?
Yes, sir.
Analysis. Any doubts?
No, sir.
No sir, not sir.
Sir, I didn't get that meshing part.
Sorry?
I didn't get that meshing part between the car and the other one part.
Meshing part.
Yeah.
Thing is there, like we have to assign the thickness for that part. So why? Because it's a surface body. Okay. So what happened here? When we specifying thickness here 20 mm, so what it will do? It will take either side half of here, like 10 this side and 10 that side. Okay. So due to which what happened, if it is getting intersected, it will not show the proper results too. So in that case, it should be in a contact, not in an intersection. Okay, that is the reason what I have done. I have changed the assigning thickness only in one direction. Why? Because anyhow, from beginning only it is in intersection position. Okay.
Okay, sir.
With, like what we can say, that thickness I changed to assigning only in one direction, not on both directions. That is the reason. Why? Because from initially only it is like in contact only. It should not be intersection. It should be in contact only. So that is the reason what I have done. I changed that value to top, so it will become as a contact. Then mesh is nothing but just assigning the, not assigning thickness, but it is generating the small particles or small elements for the body, so that it can create some finite equations. Understand, guys?
Yeah, could you just once more show that connection with contact? What to trim part? Connections, contacts, that body bonded trim to that only that part of a tree. Once again.
Yeah, connections you are talking about.
Yeah.
The thing is that in connections here, we have two types of connections. Not two types, four types of connections are there. One is what we can say bounded. Usually bounded we will not take for this one. Why? Because bounded usually will do for when the bodies are completely connected with each other. Okay, it's a kind of, suppose for example, two parts we are doing welding. Okay, two parts we are doing welding here. So in that case, what we have to do, we have to go for the option bounded. In that case, usually what we will do means we will do here frictional one. Okay, frictional one we will do here, or frictionless we will do here. Why? Because it is getting crash with that body, but it is not taking it, showing some program code, or it's showing some not taking that value here. So three are the bounded, frictionless, and no separation. No separation means both bodies are connected to each other. Both bodies are connected to each other, but the thing is, it is not take connections. Yeah, we'll check once. Usually, we will not take connections for this. So, I think connections will not take in specific time. Why? Because contacts we will do uh, when we have two bodies are connected with each other. At that time we are using contacts. But right now this should not be contact. Why? Because the car is hitting to the wall means there is no contact here. From beginning, right? After crashing it is getting connected. After crashing it is get touching with that wall, but it is not in a contact. So connections we will do for two bodies. Like for example, we have an assembly body. For example, that assembly is how we will do that assembly is either we will do weldings or we will do nut and bolt rivetings. Different types of connections are that we are using to assemble the parts. So in that case, so if we are doing the analysis of the assembly bodies, in that case we require the connections, not for this. the second case.